Hello, we are looking at lesson 7.6 called dilations. This is found on page 588 of your Geometry Part 2 textbook. In this particular problem, we have to find the scale factor, and dilations, remember dilations are not what we call rigid movement, which means it doesn't keep its same dimensions. It is the same shape, but it doesn't stay the same size. So because of that, we have what is called a scale factor. Now, if we are if the image that is created is bigger than the original, then we call that an enlargement. And if the image is smaller than the original picture, then we would call that a reduction. Now, the way that we know which one is the image is it's always the one that has the little prime. So you can see here that's R prime, T prime, X prime. Those primes are what let us know that that is the image. Now, if we look carefully at this, to find the scale factor, you always take the image and divide it by the original. So in this case, we're going to compare the lengths of corresponding sides. This is one way to do it. Notice that the original had a side that was only 4 long. The new one is going to be 4 and 8 put together, or this side, which is the image, the blue one, is 8 and 4 put together, which is 12. So again, if we take the image over the original, then that's going to be 12 over 4, or 3. And of course, we know that we can see here that the image was much bigger than the original. So it is an enlargement. One thing you're going to find out that when the scale factor is above 1, it's always going to be an enlargement. If the scale factor is below 1, like a fraction, then it means that you're going to have a reduction. So let's look at the got it and see if we can apply it to this. Now, what is different about this one is, here's my original, the JKLM, which is in black here, and then in the turquoise color here is the J prime, K prime, L prime, M prime. So the little one in the blue here, again, is the image. Well, the image is smaller than the original, so for sure we know that we're going to have a reduction. Okay, so again, you can just look at the picture and know that the image is smaller than the original. Now, how do we find the scale factor? Because I don't see any sides listed here, and unless I do the distance formula, none of these are laying straight, either up or down or sideways, so it would be, well, we could look at this right here. This one right here is only 2 units long, and this one right here is 4 units long. Remember, you always put the image divided by the original, and sometimes the original is called the pre-image. Why they do that, I don't really know that terminology, but I think of it as the image and the original. The image, because this one is easy to do straight up and down, you can just count the blocks. The image is only 2 units long. So we're not comparing necessarily, it didn't give it to us, but we can count that. This image right here, that's 2 blocks long. The side that corresponds with that, which is KL, is 4 units long. So our scale factor is going to be 2 over 4, which, as we know, that reduces down to 1 over 2. So the scale factor on this particular problem is 1/2. Another way that you can find scale factor is how far it is away from the origin, or most of the time it's the origin. This right here will tell you where it's being dilated from, and in many cases, if there's an O there, of course, that means from the origin. So what I wanted to show you here is, say for instance, we just picked J and J prime. J, which is the original image, was 2 spaces away from the origin. and J prime, which is the image, was only one space. And if you'll notice, we get the same thing as we did if we compared side to side. So that's just another way to find scale factor. If the sides are not given or they can't be found, you can literally take the distance the image was from the center or the origin, and divide that by how far the original one was from the origin, and you're going to get the same scale factor. I hope this was helpful.